Number 13, segment JK is shown on the coordinate grid. If point P is 3/4 of the way from J to K, what is the coordinates of P? So I'm gonna just give you a little visual here. If this is J, right there, we want to know where would P go. And I'm starting at J because it says from J to K.
So 3/4.
Just tell me, yeah, where do you think it might be? What would be a good guess?
Like around there.
And there. Now let's just see if there's anything we can eliminate here. So what would the coordinate be there if that by that guess?
Must have been 2.
2, 3.
So what can we eliminate this we know is not even accurate?
The
This one's out, this one's out. Okay. Okay, now here's the easiest way to do this. How many units do we go to the side? Remember we kind of did a problem like this earlier where I drew it like a triangle. Sorry, line. Come on, line. There you go. How many units do we go from here to get directly underneath the K?
12.
13.
So this is 6 left. This is 6 right. How many units is that?
12.
12. And now how many do I go up?
16. 18.
This is 12.
18.
This was 8. Here on this side, how many on this side?
16.
That's a total of 16. Okay, so what is 3/4 of 12? 12 times 3/4. That's the same thing. You can either multiply by 3 first, then divide by 4. What is 12 times 3? 36. And you divide that by 4.
9.
9. Or you could have said, because it doesn't matter where we're multiplying, dividing, you could say what's 12 divided by 4?
3.
3, and then multiply that by 3.
9.
9. Okay, so it should be 9 units over. 9 units over. We're not 9 units over. We need to go
No.
there. That's 9 units over.
So
It would be
4.
3, 4. Let's check it. You take 18, 16. I'm sorry, 16, and you multiply that times 3/4. I think the math's easier if you divide first. What is 16 divided by 4? 4 multiplied by 3.
12.
12. It should go up 12 units. So right 9 up 12 would get us to that point there.
So
3, 4 is the correct answer. Let's check and make sure that that's what the district says. Whoops, that's not what I wanted to do. I want. There we go. 3, 4. That's the correct answer. Number 14, which diagram shows 2 triangles that are congruent by side angle side theorem? Which diagram shows you side angle side? I'm gonna stop this for a moment, let you think. Which answer do you think is the correct answer here? I'm hearing some A's. Let's check it out. Does it say A? Yes, it does. Now, why is that? Because vertical angles. So what do I have here? A side, an angle, and a side. That is side angle side. If you go through, by the way, on this one, these two, since these are the same angle, what does it mean about these sides?
They're the same.
These are the same,
Oh,
and this has an angle here. They're vertical. So what would this be?
Or
You could say, call it SSA, or you can call it. Now, does this work?
No.
Not congruent anyways. Not necessarily. Not necessarily congruent. And by the way, it means it can be, but not always. Congruent. But not just that. What did they ask for? They asked for side angle side. Okay, over here we have sides. We have this angle. Did they give us anything else?
No.
No, because these are parallel, you could do alternate interior. You could say this is going to be congruent with this one. So in a way, you have side angle angle. Side angle angle. Or you could say angle angle side. But that's not what they wanted. And finally on this one, you have hypotenuse. And you would share a leg. So this is HL, very good. But they wanted Side angle siding.